starting with identifying trig ratios. Okay, so we have triangle OPQ, and we're going to draw it out because it's a little bit hard to do this stuff without a picture. So I'm going to draw a right triangle because in all of our cases we deal with right triangles. That's my right angle. Okay, so it tells me angle Q is 90 degrees, so that's the letter I put at the right angle. Other than that, O and P can go anywhere, so I'm just going to put O and P like that. If you switch them, that's totally fine as well. PO is 97, so that's over here. OQ is 65, right over here. And QP is 72, right over here. So now that our triangle is labeled, we want to know what is the value of tangent of O to the nearest 100. So let me see, where is O? O is this one. So here is our reference angle. O is our reference angle. We also want tangent. So I'm going to write so, ka, toa. Which one is tangent? It's T for tangent, right over here. So we're looking at the toa. TOA. So that means tangent of the angle O is equal to opposite over adjacent. That's what the OA in TOA stands for, opposite over adjacent. Now we're going to just put it together. What is the side opposite to our reference angle O? You can draw an arrow directly away from your angle O, and it will point to your opposite side. So I pointed to the number 72. And then what is the adjacent side? So there's two sides that are touching our angle. It's either the 65 or the 97. But remember that 97 is the hypotenuse because it's across from the right angle. So 65 must be the adjacent. So tangent of O is equal to 72 over 65. Now, 72 over 65, this is the ratio. So if it was asking for a ratio, I would just enter 72 over 65. But this problem says we want it rounded to the nearest hundredth. So I'm going to type on the calculator 72 divided by 65. And I get 1.1076921. But we're going to round it to the nearest hundredth. That means we want 2 decimal places. So we look at the third one and we see, is this a big number or a small number? Small is 0, 1, 2, 3, 4. Big is 5, 6, 7, 8, 9. So this is a 7. That's a big number. We're going to round this up. This is 1.11. The 0 rounds up to a 1 because the 7 is a large number. So I'm going to enter in our answer 1.11. Any questions on this review example? Okay, so I'm going to go enter this in. All right, let's go to the next category, using trig to find a side. We've done problems on this before as well. It's just review, so I'm just going to do one example. Okay, so our reference angle is the 49 degrees right over here. And we need to figure out, okay, what is that 3.1? The 3.1 is directly across from the right angle, which makes it the hypotenuse. Okay, so we have a hypotenuse, and we also have the side x, the side we're looking for. So is that adjacent or opposite? Well, it's right next to the 49 degrees. In fact, it touches the 49 degrees. So this is adjacent because it's right next to it. So we have the adjacent and we have the hypotenuse. So out of the so, ka, toa, which one of these uses adjacent and hypotenuse would be the ka because it has the A and the H. So ka. Ka stands for cosine. So cosine of 49 degrees is equal to adjacent over hypotenuse. So cosine 41 is equal to x over 3.1. This is the case where x is being divided by 3.1. X is on the top. So to solve for this, you just multiply both sides by 3.1. And I get 3.1 cosine 49 degrees equals x. And I'm going to type this on a calculator. and then round it to the nearest tenth of a foot. But before I go leave and type this on a calculator, before I leave this picture, do you guys have any questions? If you do have a question, type the word yes in the chat. All right, let's go type 3.1 cosine 49 into the calculator. 3.1 cosine 49. And it gives me 2.0337. Here, I'll zoom in. It gives me that. And so we are rounding it to the nearest tenth of a foot. That is 1 decimal place. So we look at the second decimal place and it says 2.03. The 3 is a small number, so we keep it at 2.0. The 0 stays as a 0 because 3 is a small number. So 2.0. All right, let's go on to the last category. This is the new one. This is the one that's based on our notes. So I'm going to do a few of these examples, okay? Let's take a look. Triangle IJK, the measure of angle K, blah, blah, blah. Okay, I'm not going to read all that. They gave us the picture already. We are finding the measure of angle J to the nearest degree. Angle J is over here. They label it with an X, so we're going to use it with X. Okay, so that is our reference angle. And we have the 16. What is the 16? Well, if I draw a line directly across from X, I will end up at 16. That means it is opposite of our reference angle. That means 16 is our opposite side. And what about the 73? What is the 73? Well, it's directly across from the right angle. That makes it the hypotenuse. So we have O and we have H out of the SO, KA, TOA. Which one has the O and the H? The SO. So the SO stands for S for sine. So sine of x degrees is equal to the O over H, the opposite over the hypotenuse. So 16 over 73. But we're not done yet. This is sine of x degrees is equal to 16 over 73. But we want x to be by itself. So how do we get x by itself? Is we do the inverse. So sine inverse of 16 over 73, and that will give us x. So before I go to the calculator to type in sine inverse of 16 over 73, are there any questions? Calculator. Sine inverse of 16 over 73. All right, and it gives me 12.660. We want to round it to the nearest degree. That's what Deltamath said. It says round it to the nearest degree. So it's 12.6. That 6 is a large number, so it should round up to 13. Our nearest degree is 13. So we rounded it up because the 6 is large. Are there any questions up till here? Okay. Submit. Let's do another one. Triangle NOP. They gave us the measurements. Find the measure of angle O to the nearest degree. So here's O. They labeled it with an X. That's totally fine. We need to figure out, is 36 and 96, are those the opposite, adjacent, or hypotenuse? Let's figure them out. 96 is directly across from the right angle. That makes it the hypotenuse. And then the 36, it shares a side with the angle X, which means it's the adjacent. So we have adjacent and hypotenuse out of the SO, the KA, and the TOA. Which one has the A for adjacent and the H for hypotenuse? It would be the KA. So that means we have cosine, C for cosine. So cosine of x degrees is equal to adjacent over hypotenuse. Now this is cosine of x, but we want regular x, so we have to do the inverse. So x would be equal to the cosine inverse of 36 over 96. And we would type this into our calculator. before I go type it into the calculator, are there any questions? All right, let's type this in. Okay, so we typed in cosine inverse of 36 over 96, and we want it to the nearest 10th of a degree, which means we are rounding it to one decimal place. So it's 67.97, and the 7 is a very large number, so that 9 has to round up. The 9 rounds up, which means instead of 67.9, we're at 68.0 instead of 67.9 because we rounded up. All right, any questions on this part? Okay, let's submit. Let's do another one. Okay. There's a triangle. X is our reference, reference angle, and we're looking for the value of x. So we need to figure out what the 61 and the 89 are. This time I want you guys to either type it in the chat or just say it out loud to help me out. So what is the 89? Is that the opposite, adjacent, or the hypotenuse? What is the 89? Opposite, adjacent, or hypotenuse? What is that? You don't have to type the whole word if you're typing. Opposite, adjacent, or hypotenuse? What is the 89? Yay! Thanks, Evelyn. The hypotenuse. Good, the hypotenuse. And I'm just abbreviating it there. What about the 61, which shares a side with the angle x, and it's right next to it? What is the 61? Adjacent. Yes. Cool. So then we have the so, ka, toa. Which of these uses adjacent and hypotenuse? Type it in the chat or say it. Yes, the ka. Okay, so cool. That stands for cosine. So cosine of x degrees is equal to the adjacent over the hypotenuse. So it's 61 over 89. And then from here, I don't know how else you would type this, so I'll just say it. We're going to do the cosine inverse of 61 over 89, and that will give us our x value. So before I type in cosine inverse of 61 over 89, does anybody have a question on how we got to here? Let's go enter this in. All right, it gave us 46.7. We want to round it to the nearest degree according to Deltamath. So we have 46.7. The 7 is large. That means we round this to a 47 instead of a 46. So we rounded it up. Okay. Let's see. I could do one more. I don't know. I don't know how many examples you guys want. All right. Let's screenshot that. Okay, so this time our reference angle's up here. We have the 4.8 and the 6.7. Let's figure out what those are. So you guys can type it in the chat again. What is the 4.8? What is the 4.8? Adjacent, opposite? Yes, opposite. Cool, I got 2 volunteers, I think. And then what about the 6.7? What is that?
Hypotenuse.
Yes, hypotenuse. Okay. Okay, so we have the opposite and the hypotenuse. Is this a so, is this the ka, or is this the toa? So, yes. Yay, I got like 3 or 4 people there. All right, so is the sine. So sine of x degrees is equal to the opposite over hypotenuse, so 4.8 over 6.7. And then to get the x by itself, we're going to do the sine inverse, 4.8 over 6.7. And that will give us our x, whatever that is on the calculator. I will go type it in just a moment. But before I do, are there any questions? All right, let's go type this in. Sine inverse of 4.8 over 6.7, and that gives us 45.759. We want it to the nearest degree, it says. So we look at the 0.7. That 0.7 is a large number, so that means we're rounding up the 45 to a 46. So all right, final answer is 46. Yay, okay, so we did 4 examples here. If you guys do need more, just ask me in the breakout rooms, okay? So I'm gonna end the recording.